Hello, welcome to the Neural Network implementation for the SMLC Neural Networks course. We will begin this implementation by importing Keras, by importing our libraries. First, we will import all the normal libraries like Pandas, NumPy, Keras, TensorFlow, and Matplotlib. You can see us doing this here, 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 and here. Then, from TensorFlow, we will import the MNIST library, the toCategorical function, and the layers class. We will get into all of these later. We will begin by loading our MNIST data into our xtrain, ytrain, xtest, and ytest variables. We will then reshape the xtrain list into a list shaped with the 6784, which will allow our dense neural network to be able to train on this data. Then we will normalize our data by dividing every value by 255. We will do this for xtrain and xtest. We will then print out the xtrain shape, which we can see right here. Then we will turn ytrain and ytest into categorical data. What this means is that it is one-hot encoded, or that it is a list of zeros and ones with 1, 1, and the rest of the values are 0. And these values show what the value of the y is. For example, if we have this list, it corresponds to 1, or the number 1 in our MNIST data, because the first index of this list is a 1, meaning that the number will be a 1. For this, the 0th index is a 1, so the y train for this is, or the y value for this is 0. Then we will create our build model function. To begin, we will define a function right here, create our model as a sequential model, which means that it has many different layers. Then we will add 3 dense layers. The first 2 are the exact same with 56 units and a rectified linear activation function. Then our final one, which is going to be our output layer, has 10 neurons because there are 10 different distinct numbers for ytrain. And our activation is going to be softmax because it is going to be our output layer. Then we will compile our model, meaning that we're going to add our optimizer, loss, and our metrics. Our optimizer is going to be Atom, which is going to be used often in most neural network applications. Our loss is going to be categorical cross entropy because it is a categorical data, hence the categorical. And our metrics are going to be accuracy, so that we can see our accuracy when we are training. Then we're going to return our model. Outside of the function, we will define our model to be the output of this build model function, which is right here. We will fit this data to xtrain, ytrain, and ytrain. We're going to have 5 epochs, and we are going to have our validation data be xtrain, xtest, and ytest. We are going to print out the summary, which you can see right here. This entire thing is the summary. We have this dense layer, and this dense layer. We can see 47,000 parameters and 0 non-trainable parameters, which is normal. And our output shape for these two are going to be 56. You can see 56 neurons right here. And this output shape is going to be 10. When we train, we will see this program training. So we'll begin by running from the top. It is going to connect to runtime in a second. And we can see this top portion running. Then this will run. And when we train our model, we will see this animation of source happening. We can see the loss going down, the accuracy going up, and we can see our validation loss and validation accuracy. This data set will train very quickly. Most data sets do not train this quickly, but we can see it quickly training over the course of 5 epochs. And our final accuracy is going to come out to 92%, which is normal. And our validation accuracy is going to be right around there. Alright, thank you so much for watching.